In this case, we set our antenna to have a frequency, our system to have a frequency of 28 gigahertz, and we created this massive MIMO array. One of the first things we then wanted to do was look at how the beams, how the fields propagated through our system. So we placed a field map of 64,000 receivers, and we calculated the fields on this field map as a backdrop to understand how the fields propagate in our scene. Now we can see here that from this base station we get a lot of energy that propagates down the street directly in front of the array, and we also get strong fields propagating to the sides. And what this first field map represents is the fields that we would get from a single dipole antenna before we apply any of the beamforming techniques to our array. So these are the initial propagating fields from each of our dipoles, and this is the starting point that we can then use to try to direct beams to all of our users in this cell. If we follow the route that's propagating through this cell, we can plot the power, the received power along this route. And here we can see that the power increased up to a position here near the peak, which was about the point where the corner right in front of the array, and then it began to drop again as it drove down the street, and then drop off as it passed around the corner at the end of the street. One of the other things that we see here as well is a lot of multipath fading, the peaks and nulls that we see as the device is moving along. And this is caused by constructive and destructive interference between all of the paths in our simulation. So when we then simulated this with the full MIMO array and plotted this received power for each of our 128 transmitting elements to this device as it moved along the street, we see a lot of variation, even though these antennas were only half a wavelength apart, which at this frequency is spreading over just a few centimeters from side to side and top to bottom. We see a great deal of variation in the multipath, and although there is similar fading going on, the peaks and nulls are happening at different places on these different elements of the array. And this variation is precisely what Massive MIMO and MIMO in general can take advantage of to try to direct beams and optimize how the energy is sent to the individual devices in the scene. Now we also see a general trend here of some higher peaks and some lower values. The device moving down the street had a vertically polarized antenna, so in general the received power to this device from all of the horizontally polarized elements was much lower than it was from all of the vertically polarized elements of our array. So next, if we want to look at some of the beamforming, we've chosen two devices, two positions along our route that we want to look at the beams to. The first one is shown in a large red dot here, and then as the device continued along the route and around the corner, we have a second position shown in the red dot in the middle of the screen here. So the first position was the 20th point along the route, and when we applied our beamforming techniques, we can see a slight shift in how the power is being directed. This isn't a perfect singular beam. We actually have some different lobes. A very strong lobe is reflecting off the side of a building and making its way to our receiver point. There's another lobe that is coming along from the side, along the side of this blocking building. And there are also other side lobes that go down other streets and down the main street in front of the array. But we can clearly see quite a change over the previous field map showing how the energy has been redirected toward this device. If we then, so this is showing the maximum ratio transmission technique, the one that tends to maximize the power to our device without respect to any other devices. If we then look at the beam to the second device position, we can clearly see that the beamforming has now moved the beam to shoot directly down in front of the array. It's a very strong beam, and again, this is using maximum ratio transmission. It's directing a very strong beam toward our intended device, and it's not considering it in any way the other devices in the scene and whether this is generating interference toward them or not. Now the second technique that we looked at was called zero forcing. looking at these same two positions again. First, we have our first beam, and again we can see that it's taking advantage of this strong reflection off the side of the building and some diffraction around this the side of this obstructing building to get a strong signal to our device. However, we notice a slight difference this time. If you look closely, you'll see that each of the other devices happens to be sitting within a null in the pattern. And so our technique has made an attempt, the zero forcing technique has made an attempt to try to minimize the interference to all of the other devices. The beam to our intended device is not quite as strong, but the interference to the other devices has been significantly reduced. If we look at our second position along the route, we now see a much more intricate beam pattern that was formed to try to get to the second position. Because there are several other devices blocking and beyond this device straight down the street, the zero forcing technique has actually created some beams. There's a small beam that heads straight toward the device, but some of the strongest beams are actually reflecting off the buildings to the left and to the right. And again, as we look around the scene at the other devices, the stationary devices in the scene, we'll see that they are in individual nulls that have been created by the zero forcing technique to try to minimize interference to each of those devices. Next, if we look at an animation of how these beams changed along the full length of this route, we can watch how each of these techniques performs as the device is moving. So as before, we see the strong beam following our device in red that's moving along the route. And as this beam follows it, there's no attempt to minimize the null, so you see it sweep across all of the other devices, and whenever our intended device moves in front of them, they receive interference. Next, if we look at the zero forcing technique, we see a similar set of changes occurring. However, we see the pattern very carefully shifting in ways that is continually keeping nulls on our other devices. The beam down this main street with several other devices is clearly not quite as strong as it was for the maximum ratio transmission, but the technique is continually keeping the other devices in a null and minimizing their interference.